accelerate moves forward, it requires a state of motion, right? Bus is moving, but luggage kept on the roof, owning its inertia. They are in rest, right? Because bus is moving, and along with that, they are moving. Tend to remain in the state of rest. Hence, with the forward movement of the bus, the luggage tend to remain at its original position and ultimately falls from the roof of the bus. Okay, so see, whenever bus will apply brake or bus will stop anything, it will affect luggage. So just to stop that, they are kept on the roof of the bus with a rope. Okay. Okay. Jocelyn, you are also done. I think Jocelyn is having some network issues. Okay, now this is very important. A batsman hit a ball when they roll on the ground. After covering a certain distance, the ball comes to rest. Right? The ball stops because of what? There is a force on the ball opposing to motion. So, because of this, ball stops. The reason is a batsman hits a cricket ball when they roll on the level of ground. After covering a shorter distance, the ball comes to rest because there is a frictional force on the ball opposing its motion. Okay, so you will be writing this. You will be just writing this. See, there is a fall. This. Okay, no need to write everything. Done, guys?
Done, ma'am.
Now see, next question, very easy. A truck starts from a rest and rolls down in the hills with a constant acceleration. It travels a distance of this in this. So this is a distance and this is your time. You have to find acceleration and then you have to find force acting on it if the mass is 7 metric this. 7 metric, 1 metric is equal to this. So first you will convert. So over here initial velocity is 0 and time taken is 20. Distance covered is this. From here by using this formula you will find out A, right? Because you have U, you have T, you have S, but you don't have A. So you will put the value and you will get the answer. Okay, once you got A, you have to find force. You know the formula, mass into acceleration. So this is mass, which is already given to you. This is 7. In 1, it is 100 kg. So in 7, it will be 700 kg. So 700 multiplied by 2, you got this. Clear?
Yes, ma'am.
Okay.
Finished, ma'am. Done, ma'am.
Okay. Now, next is this. A stone is of the stone of 1 kg is thrown with the velocity of this across the frozen surface of a lake and comes to rest after traveling the distance. What is the force? So over here you have U, right? You have the distance, right? And also you have the mass. You have to find the force. So for force, what is the formula? Mass into acceleration. So over here you have velocity and S, right? So you can find yes. So you can find out V, sorry, A. So V square equals to U square plus 2AS, right? U is given, V is automatically 0. So over here, first you will put the value and from here you will get A. Okay, right? Once you got A, then your mass is 1 kg and now you will get the force. Mass multiplied by acceleration. 1 multiplied by minus 4, which is minus 4 newtons. So hence the force of friction between stone and ice is this. Clear?
Yes, ma'am.
Okay, so first of all, remember one thing from the previous chapter itself, the 3 divisions which we did, the 3 derivations that are also very important. Okay, because in this case, in this chapter also you are going to use them, and the question will be coming like this only, right? Not in that way, direct question like this they'll be asking you. So be ready. So write this, and I'll scroll it down once you are done here.
Finish, ma'am. Done, ma'am. Finish, ma'am.
Both of you done?
Yes, ma'am.
Now next, a 800 kg engine pulls a train of this wagons, each of 200 kg along with a horizontal track. If an engine start at the force this and the track offers a friction force of this, then you have to calculate first acceleration force. Okay. So first the net acceleration force you have to find. So how you will find? You have force, right? And you have to find net. Net means you have two force over here, right? This and this. Very simple. So net means always division. So between two forces you have to find the difference. Net means difference. So you have two forces, you will simply subtract it, right? 4000 minus 5000, you will this, and you will get this. Clear? Like this is 40,000, sorry. 40,000 minus this, you will get 35 Newton. Very easy. Whenever you get net, that means you have to find the difference. Second, you have to find the acceleration of the train. You have to find A. So this is basically, you know the formula, F, a force equals to mass multiplied by A, right? Over here you have mass, right? Mass multiplied by number of wagons. So your mass is this and your formula is MA. So in order to find A, it will be F divided by M. So what is your force? It is this. And what is your mass? This is. And you got this. Clear? Now next you have to find the mass of the force of one wagon on wagon 2 you have to find. So for a mass of 4 wagon, basically it is this. Okay. And acceleration of the train you already find it out. So you have to find 1 on 2. So it is 800 multiplied by, sorry, 8000 multiplied by this, you got this. Clear?
Yes, ma'am.
Okay. So remember this net word. Whenever you get net, you have to make sure, net means you have to find the difference. So quickly do it, then I'll scroll it down.
Ma'am, can you please go repeat the question? Ma'am, can you scroll? Finished, ma'am. Finished, ma'am. Done, ma'am. Done, ma'am.
Okay. Now moving to the next question, which is an automobile vehicle has a mass of this. What must be the force between the vehicle? Okay. Vehicle on the road, if the vehicle is to be stopped with a negative acceleration. Okay, so mass is given, velocity is given, acceleration is given. So you already know it is very, very simple. Mass into acceleration, just put the value, get the answer. Right? But over here, see, they have written with a negative acceleration of this. So over here, they have not mentioned minus 1.7, but they have written it. So you have to consider it minus 1.7. Yeah.
Yes, ma'am. Finished, ma'am.
Done, guys?
Yes, ma'am.
Okay, now next, what is the momentum? You have to find the momentum. Okay, momentum is also mass into velocity, right? So you already know this. What is momentum out of this? It is d, mass into velocity. Clear? So quickly write it down in 1 second.
Finished, ma'am.
Okay. Now next, using horizontal force, this we intend to move a wooden cabinet across the floor of constant velocity. What is the frictional force? So force of this is applied to the forward direction. Thus, the Newton's third law of motion, an equal amount of force will act in the opposite direction. This opposite force is a frictional force exerted on the cabinet. Hence, the frictional force of 200 Newton is exerted on the cabinet. Clear?
Yes, ma'am. Finished, ma'am.
Now next, this one. Wait, I think 12, 13, 14. How many questions we have? 15, 16. Okay, these are numericals. Okay, 16, 17. How many questions we have? So many questions. I think this is the last, right? Okay, wait. A minute. Let's just do some theory questions. Okay. Hmm. According to third law of motion, when we push an object, the object pushes back on us with an equal and opposite force. If the object is massive truck parked along the roadside, it will probably not move. A student justified this by answering that two opposite and equal forces cancel each other. Comment on this logic. Okay. So see, the truck has large mass. Therefore the static friction between the truck and the road is always very high, right? And is also very high. To move the car, one has to apply a force more than the static friction. Therefore, when someone pushes the truck and the truck does not move, then it is said that the applied force in one direction is cancelled out by the frictional force of equal amount acting in the opposite direction. Therefore, the student is right in justifying the two opposite and equal forces cancel each other. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, Justine. Then rest are numerical, so you will try them on your own. Okay, just leave the momentum part. Okay, momentum is not in the syllabus, so you can leave that. Okay, and rest, I think everything we did. Okay, so if you have any doubt, you can come up with the doubt in the next